Hello everyone. In this session, we are going to see photoelectrochemical water splitting for the hydrogen production. Basically, it includes the water and the sunlight, which are responsible for the hydrogen production with the help of specific semiconducting materials, also known as photoelectrochemical materials. So basically, in concern with the hydrogen production, there are several methods that can be utilized for the hydrogen production, such as biomass gasification, biomass-derived liquid reforming, natural gas reforming, thermochemical water splitting, photoelectrochemical water splitting, and the electrolysis. So in concern with the present session, we are focusing on the photoelectrochemical water splitting, which is nothing but the method for the hydrogen production in which hydrogen can be produced from the water using sunlight and specialized semiconducting materials known as the photoelectrochemical materials, which use the sunlight energy to convert water molecules directly into the oxygen as well as hydrogen. So basically, it includes the water dissociation with the help of sunlight and that designed semiconducting material. Okay. So in concern with the photoelectrochemical water splitting mechanism, the photoelectrochemical setup includes anode, which is positive electrode, and the cathode, which is negative electrode. The anode is nothing but the photoelectrode, which are responsible to absorb the sunlight. So basically, these are the designed working electrodes, semiconducting based electrodes, while the cathode, in most of the cases, it is platinum one because it is chemically inert. So both anode and cathode are connected with each other through the external circuit by means of the bias as well as the potentiostat or potentiostat actually. So whatever the semiconductor, so as discussed, the anode, that is photoanode, includes the semiconducting material having the specific conduction band and valence band. So initially, in concern with the mechanism, what will happen? Whatever the sunlight energy incident on the semiconducting material, there is a absorption of that sunlight using that semiconducting material. So there is a photo-generated charge carriers can be obtained. So these photo-generated charge carriers nothing but the electrons and holes. So whatever the electrons generated, they get excited towards the conduction band of the material by leaving the holes at the valence band. So whatever the electrons generated due to this absorption, that is sunlight absorption, these electrons supposed to transfer from the anode to cathode by means of substrate and then by the external circuit. Okay, so at the cathode we are getting the photo-generated electron that actually moved from the anode to cathode by means of external circuit. And in concern with the holes that are present in the valence band, they are responsible for the water oxidation reaction, whereas holes react with the water to produce oxygen along with the hydrogen ions. Okay, so this is the water oxidation that takes place at the anode. Whereas whatever the 4H plus ions generated at the anode, they are transferred towards the cathode. They are transferring towards the cathode. So these 4H ions plus the whatever the electrons that actually gathered at the cathode, they are supposed to react with each other for the reduction reaction. So water reduction reaction, by treating the 4H ions plus electrons, we are getting the hydrogen gas molecules at the cathode by means of photoelectrochemical water splitting. So this is the basic photoelectrochemical water splitting mechanism, which is responsible for the oxygen as well as hydrogen production. Thank you.